Here. Number 2 is right there on lay television.
I didn't copy down the negative. Huh.
Well, that was a mistake.
But I got everything else right. And the other thing you right. A lot of it.
Number 4 is that one. This away, that away.
Okay, but like I used a fraction because that's what you've been making us do forever, and now it's using decimals.
So sad. Either one's fine. Number 6 is that guy. Excuse me. Number 8 has the minimum of negative 14.25. Its domain is all real numbers, and the range is greater than or equal to negative 14.25. Number 10 is invisible.
It's invisible. You didn't have to do it.
No, that's false.
Well, I'm glad I did.
Number 10. Where are you? 41, 8, 9. Oh, there it is. 10 has a maximum at 0.25. Domain is all real numbers, and the range is greater than or equal to 0.25.
Greater than?
Excuse me, less than. Okay. Number 12 is right there. Insufficient storage space.
How could you, Sean?
No, that's not on my phone. That's on the TV or the Apple TV or something.
How could you, Sean?
So who knows? All right, number 14. It's that one. And 16 is that one. And 18 is that.
Whole page.
$20 is there. $22 is also invisible. There it is. Has a minimum at 0. Domain is all real numbers, and a range is from 0 to infinity. Number 24 has a minimum at 0. The domain is all real numbers, and the range is from 0 to infinity. 26 has a maximum at 22/3. The domain is all real numbers, and the range is negative infinity to 22/3. 28 has a maximum at 15. Its domain is all real numbers. The range is negative infinity to 15, including 15. Number 30 has a maximum at 55. Domain is all real numbers. The range is from negative infinity to 55, including 55. Number 32A is 800. Number 32B is $24,000. So, what questions do we have on those? 2 and what? And 4.
6, 8.
And all the rest? Wow, this is very green.
Green as the color.
as in the white balance is very green. It's okay. Fix it in post. Luckily, I have finally started being smart and using resolve, and I can just click auto and it does an amazing job.
Yay.
Okay, number 2, apparently.
They're all like, yeah, all zeros.
What?
Like,
Number 2, we've got f of x equals negative x squared, negative 6x squared.
would that make B and C, like, you write it out as like 0?
Yep. Yep, if we were writing it in standard form, then B and C would both be 0 in this particular problem. Oh yeah, I don't want to use this machine. I forgot. It's not bad, it just needs to be descaled. And so it'll make like almost espresso, but kind of gross espresso right now.
Okay.
Okay. Find the y-intercept equation of the axis of symmetry and the x-coordinate of the vertex. Great. How do I do that?
What did you just find the y?
How do I find the y-intercept? Let's start there.
There's no y.
It's 0. The y-intercept is 0. Oh, I didn't put it into the coordinates. I just said the y-intercept was 0.
That's fine.
Got a dot right in the middle.
Okay. Now how do we find the equation of the axis of symmetry?
That is the B over the B over 2A.
Mm-hmm.
B
So it's 0.
Over another.
Negative 0 over 0. 2 0.
No, because then that would be a totally different thing.
What?
6.
A is negative 6. If it was a 0 in the denominator, then it wouldn't have 1, because it would be undefined.
Yeah.
But you'll see that in pre-cal. we start, when in pre-cal, you see all of this again. You get a graphing calculator this time, and sometimes stuff goes off the rails, and the pretty parents kind of like get inbred.
Do you have a negative 0?
No. But this ends up being x equals 0 in the end, yeah?
Yeah.
Great. Okay, so
Like, do you have
What
to
are
let
we-
that all out if there are any of the zeros? Because you can just know that x is going to be.
yeah, you could. I wouldn't count off if you just wrote x equals 0. That would be fine. That would not be a problem on this particular problem. So
Right? Is that next?
the x coordinate of the vertex is 0.
So, what are, so B, is the axis of symmetry and the vertex the same thing?
The x part is. The vertex is the point. So it may be it'll be that, but maybe moved up or down. Right? So the x part and x, yeah, it's the same thing.
So why do we know it's 0? Just because
Because this is how to find the x part of the vertex. So 0, and then does it ask for the rest of the vertex?
It just
Surely.
asks for the X.
Oh, table of values that includes the vertex. So how do we find the vertex? The y part of the vertex now.
We plug in
Put that in for the x.
Yeah.
and we already
So
know that.
f of 0 equals negative 6 times 0 squared, which is still 0. Great.
It's all 0.
So those are all part A. Great. Part B is to do the rest of the table. So what numbers are we going to use for x? Sounds great. We can use our old standbys. There's no horizontal shift or anything like that. So we may as well just use the regular ones. This one we already know is a vertex. We just figured that out. It's great. So what's negative 2 squared?
4.
4 times negative 6 is
Negative
negative 24. Negative 1 squared. 1 times negative 6. And it's symmetric, and that's the vertex. So the other side are just those, right? Easy money.
Yeah.
What?
Because you multiply by negatives.
And then we grab the dots, put the dots on the board. And then we, something like that. Yeah, it's great. Do slightly better job on your paper, but only slightly.
You just put the points and then try and draw.
Like that.
And
Yeah.
fail because you can't draw.
Looks great. It's glorious. Okay. What other questions do we have?
Number 8.
Ocho. Number 8. Determine whether each function has a maximum or minimum value and find that value. Then state the domain and range of the function. No graph required.
Yay! No graph.
Okay. Of. Wasn't that what got you in trouble? You should go to bed sooner.
I went to bed at like 11. That's soon.
So, assuming that you need 8 hours of sleep, which is a poor assumption, you probably need 10 at your age to be in a healthy place. You probably need a consistent 10 hours of sleep. But we'll assume 8, because you could do 8. 8 is possible. If you went to bed at 11, how late could you stay up until it broke? How many hours would that be? You could wake up at 7, right? But you have to wake up. Yeah, I was about to say you got to wake up earlier because you got some sort of Bible study or something, probably, right? Right. See, so you cannot go to bed at 11 and be okay with any amount of consistency. You could do it periodically and be fine.
A few years ago, I did my sleep cycle stuff, and I learned that I need 9 hours, not 10.
Well, and that'll change over the course of your lifetime. Like different phases of your life, it'll be different amounts.
Like 14.
But
Well, yeah, but
So,
I mean, 'cause my
that just-
cycle's in 3 hours, but I can't.
it was at that time.
I just sleep whenever I sleep and I
So I
don't.
gotta do
Yeah.
that.
So even more reason why 11 o'clock is too late for you.
I go to bed between 10 and 11:30.
So if you do in fact need 9, which is probably a good prediction, 9, 10, maybe even 12, you might not need that much time, right? Because you're, a teenager. That's the thing about teenagers is they need the most sleep of their life pretty much, and they get the least.
She gets 4 hours.
It's bad planning. Okay, so is this going to have a maximum or a minimum? It's going to have a minimum.
Huh, that's what I thought.
We're like,
The peer pressure changed.
I look at A,
12.
and I look at whether it's positive or negative. What is A in this? Not C, A.
It's positive.
It's positive 1, right? And so this is a parabola opening up, right? And so therefore it's got a minimum, right? So it has a minimum. Now how do I figure out where the minimum is?
Find the vertex.
Find the vertex.
Yeah. Ultimately I find the y part of the vertex, right? Not the x part. The x part is not the minimum. I need the y part. So, but in order to find the y part, I gotta find the x part. So we're gonna do negative b over 2a, right? So what am I going to put here? 3. What am I going to put here? 1. So it has a minimum, well, just kidding. It has a minimum at x equals this, but that doesn't tell us what the minimum is yet. Negative 3/2, right? Now I need to find the y part to actually get the minimum, right? Right. Sorry.
So we put that in.
Yeah.
Lesson.
Oh no. Time for that.
It's okay. You have a calculator.
You don't need a calculator for this problem, kids. You can do this in your brain. What's negative 3/2 squared?
3 and negative 3/2. 3 and negative 3 over 2.
How about 9/4? Square the top, square the bottom, 9/4. That's why you don't need a calculator. This is not difficult math.
It's so hard.
Stop and think, yeah?
We're not so
Fractions
You are, you just don't slow down enough to remember your smartness.
But it's still scary.
2 1/4, right?
It's 9 halves. Negative, right?
How'd you get that? Oh, 'cause you did that.
Because I did math. That's what I'm telling you. It's not actually that complicated, yo. It really is pretty easy. Then I can still, you don't need no stinking calculator right here either.
But calculator's only
18.
no. This is bringing me back to like 5th grade when we were like.
Good. The more fluent you are with this, the easier all the stuff's going to be. Because I'm telling you right now, we're going to start doing fraction stuff up before too long, and we're going to throw letters in there. So the better you are at remembering this now, the easier that's going to be, right?
But I haven't done that since like.
Because common denominator, right? So I had to multiply times 2 to turn this one into a 4. I had to multiply times 4 to turn this one into a 4 in the bottom.
My early middle school math
Right?
was not very
Good.
well because of COVID.
So negative 9 plus negative 48 is negative 57/4.
That's what I got my thing.
So now what I would do, now here's the deal. Here's the deal, boys and girls. You can do this, and you can do this on your paper, but if you try to do this without double checking these pieces, write it down like I did. Now this one, I would, if it were me, I would go ahead and punch these numerators in my calculator to make sure that I had done it right. So do that. So 9 minus 18 minus 48. And make sure negative 57 is what we want. It shouldn't just be Malcolm sitting there punching buttons. It should be like 10 people pushing buttons.
Negative 57.
You shouldn't have said, because you were the only one pushing anything at that time. You're letting other people glean the fruits of your labor.
But that's the best way to get stuff.
So it has a minimum at negative 57/4. What's the domain of this function?
Going down to
Domain. X, left and right.
negative 3.
Does this, when we graph this, if we were to graph this, does it ever stop going left? Does it ever stop going right? So what's the domain of this function? All real numbers. Written in interval notation, because that's what we do in Algebra 2. How do I write that?
The
Negative infinity to positive infinity.
They look like fish.
It matches your face. It's fine.
Bird.
Bird. What is the range of this? No, because it does have a minimum. It stops at the bottom. So what is the lowest point on our graph? Negative 57/4. Now, does the range include negative 57/4 or does it not include? It includes it. It can be that. It just can't be less than that, right? How do we say includes that in interval notation?
It says the greater than or
Is this really the first time we've talked about interval notation in this class?
Apparently.
Apparently. Including uses a square bracket.
Yeah, I don't.
Not including is a round bracket.
I think that's been mentioned like the one time.
And you can use negatives because so let me give you a counter example it'll be easier to understand. So if I have this, we're going to talk about these later, but if I have the function s equals, let's do one that's even a little more complicated just to make sure we understand what here is here. What can't be in a square root?
Negative.
A negative number can't be in here. So x minus 3 has got to be greater than, but not equal to 0, right? So in this case, x would have to be greater than 3, right? So, but not equal to, because you couldn't have a 3. No, or equal to. It can be 0.
Oh, yeah.
It can be 0, right? So it can be 0. I don't know what I'm saying.
Square root of 0 is fine.
Oh, I'm thinking of a fraction. Just kidding. Let's do this one. Let's try this. Square root of 0 is easy. Okay. let's talk through this one. What can x not be in this problem?
0. Or well.
X can be 0, but the denominator can't be 0.
Can't be 2.
So this would be not including 2. Right? So that's what we're talking about. It can be that or it can't be that.
So it's not including infinity? It's not.
Okay. Infinity is never included because you don't get there. Right?
You can never.
Yeah, so infinity is always a round bracket. And what I was about to say before you asked your great question, and then I went on a whole tangent explaining it, we always write interval notation lowest to highest. It always goes that way. Always low to high. Make sense?
And if we wanted to like not include the negative 57 or
Then it'd be a round bracket. Yeah. But it does include, because it can be.
So you'd have to like, never mind. I couldn't say it properly.
Okay. Makes sense? Easy peasy?
Sure.
And so apparently, since this is the first time we're talking about this, apparently,
According to us.
according to y'all, I mean, it might be, I don't know.
I'm pretty sure you wrote it down like that once, and we asked, and you said it was in equal notation. That it
This is how we write ranges of things in this class. And in fact, if you go to college and you do college algebra, this is probably how you're going to write it. The only time we would not do this is in pre-cal. We learn set builder notation. And really, the only time you have to use set builder notation is if it's not all real numbers and it's just like integers. But you don't have to care about that till next year if you end up taking pre-cal or possibly in college algebra, depending. Okay. What other questions do we have? 14?
14th question.
No.
Oh, this is our 7th question, Rocco. Of the book. In the
It's not
page.
14th question, but
In the page, the specific page.
I got that.
It is, no, it literally is.
So, if you want to be obnoxious, you really got to kick it all the way up because it's not the 14th or the 7th on this page because each one of 1 through 6 have 3 questions in them. And so do 12 through 21. So if you want to be obnoxious and annoying, you may as well like push it to 11. So, you know.
I didn't know.
Well, you did the homework, so, you know.
Yeah, I don't remember how many questions there were in each.
All right. We're supposed to do the y-intercept. Y-intercept is at -5. True enough.
You have 0 and negative.
It is a point, so that would be the best answer. Axis of symmetry, right? What am I going to put right here?
0.
And here?
1.
1.
Sideways H.
Now you put that in for X.
Sideways H. What kind of silly things are you saying? Where is this H? You talking about this?
Yeah.
The H with a tongue coming out of it? I guess. Anyway, okay. The rest of the vertex, f of 0 equals 0 squared minus 5, which is also 0.
See, that's why I like the ones that are missing.
-5.
Wait, where did you get?
Oh, it's not also 0. What are y'all saying?
What? How's that not also 0?
Well, the x part is.
It's -5.
Oh, yeah. 0 like that.
I don't know what y'all are talking
The X is 0, the Y is -5. You goofy goober.
So, you're good. What? It's not always just
No.
I know like 3 people would say that.
In this case, it is the same because it didn't move left or right any. Which we will learn ways to find that this is actually technically inverted. We will learn how to put this in vertex form and be able to just look at the equation and tell where it is. But for now, you just plug it in and that's what happens, right? All right, we'll learn, once we learn completing the square, we can learn how to put this into vertex form, and then you can just look at it and be like, yeah, it's a parabola that went over here and went like that, right? I mean, it's great, easy money. But for now, this is what we have to do, right? And then we graph it. Put dots. Oh, well, you need a table, right? This didn't move left or right any. So we can just use our old standbys.
Can we do an example where it does move?
So -2 squared is
4.
-5. -1 squared is 1 minus 5. So then we put some dots and it looks like this.
Yay.
Pretty.
It looks exactly like that, Sean.
Exactly. No differences to that.
Good doppelganger.
You should definitely take more care on yours, like when you do it for real, than this one. The last one was kind of like close to what you should do. This one, like, don't do it like that or I will count off. Okay. So one that doesn't move, that it moved, whatever I'm trying to say,
To the left or to the
moves to the left or to the right. Like,
Horizontal.
how about number 9? Except that one we're not supposed to graph. So how about number, let's do, how about 6?
Yay. I did 6.
I did 6 too.
14? Yeah, yes,
Okay.
yes. I thought you were talking about number 6, and I was like, no, definitely not.
It looks that merged to this side.
We're doing number 6.
We're going to do number 6, because Taylor kind of asked for it.
It would also be helpful to have as an example.
I'm glad for your vote of confidence. It's so sweet. 2x squared minus 8x plus 5. Y-intercept.
-8 plus 5.
Why do you give your X's tails?
Because why not?
Because they look like a baby time symbol if they don't have one.
You just use
My
a
intercept
dot
is
for
0, 5.
Yeah, I do now, but like when teaching like middle school or pre-algebra or something, then don't. So I just started writing them in cursive, and then they are in cursive. Great.
I have to add a tail to y, otherwise it looks like a 4.
There you go. Axis of symmetry.
I give B a tail, or else it looks like
What's going to go right here?
2.
no.
-8.
Oh, yeah.
And here,
2.
so x equals, ka-chink, chink, positive 2. Now the rest of the vertex, f of 2 times 2 squared minus 8 times 2 plus 5. What's 2 squared?
4.
Times 2?
8.
8. And then -8 times 2?
Negative.
-16 plus 5. And then 8 minus 16 plus 5, -3. So the vertex is at 2, -3. Okay. So this did move over. So when we're going to build our table, it doesn't make sense to use -2, -1, 0, 1, 2, because that's like only half of the graph, right? That's not going to be helpful. So what should we use? What would actually make sense?
2, 3, 4.
0, 1, 2, 3, 4. Sounds great. You want your vertex to be smack in the middle, right? That's our goal. This one we already know. We put a 0 in there. We actually also know that one as well. That's nice. Don't do extra work if you don't have to. We plug a 1 in there. 1 squared is 1 times 2 is 2. Minus 8 is negative 6 plus 5 is negative 1.
You would have gotten so mad at me if I did that in pre-algebra.
If you didn't also, write it down, whatever else, and maybe else, I don't know.
You'd get
That's
it
because
multiple
we
times.
don't know.
That's probably true.
Just think of it.
That's true. Because pre-algebra, we're working on very different skills.
You're learning like 3x equals 2.
What?
Simple math.
We don't need. Great. Then we go and draw our graph. We put dots where they belong at 0, 5, at 1, negative 1, at 3, negative 1, and at 2, negative 3, and then this one over here. And then you connect the dots with a little round butt and go up to the thing. Great. What's the domain of it doesn't ask for this. What's the domain of this function? What?
Everything.
All real numbers. What's the range of this function?
Going down to the
Negative.
3 up to forever.
Great.
We did math.
We did do math. Any other questions on this lesson? Nope. You want to put the vertex in the middle of your table and then go on both sides of the vertex. So yes, but we picked them on purpose. I mean, we could have used any points, but what? This is 6. Oh, 26.
Why do we need 10?
Does 26 have a maximum or a minimum? Does not have a minimum. No. Let me write it. 26 is so sneaky. They were so rude on 26.
So something like that happens, can you just like rewrite it correctly?
You should. That's totally what I would do.
How about 8
Oh
has
yeah,
an
they
X
were
on it?
sneaky on that one. I remember this one. I was like,
8 has an X. Okay. Yeah. Yeah, just
I
put
looked at
that
it and
down.
then it made sense.
Yeah. Which we, because we're smart, would rewrite it like this.
Hey Sean. Is
What?
Negative 3x.
I don't know.
They did.
We're supposed to have him do the whole problem like that.
And then tell him it was actually 3.
I wouldn't have redone it because the work would have been the same. We just would have got a different answer.
Yeah.
So it has a maximum
A number. Yeah.
what's going to go right here?
8.
And here?
3.
Negative 3. So positive 4/3. That's what I get. Y'all get the same?
I mean, it's 8/6.
I got the same too.
Did you actually do it?
I poked my calculator.
You poked your calculator? Okay.
That's what you told us to do.
I want you to do here, then here, but yes. Yes. Here, then here, always. I yell at my Algebra 1 kids that all the time. And it doesn't stop for you guys. Do here and then here. Because you'll make less mistakes and you'll learn more. Okay, but that's not the maximum yet, right? What do we got to do?
We gotta plug it in.
Plug it in, plug it in.
And then we get the numbers that are hopefully right.
Negative 3 times 16 ninths
4/3.
squared
Yes.
plus 8
So you just randomly decided to walk
times 4/3 plus 2.
Makes
I just skipped a step. That's all I did. That's all I did.
It made it easier though, in the long run, hopefully.
Not easier, shorter.
Shorter in the longer run.
now you multiply.
Multiply the numbers to get the next numbers.
And we get negative 16 thirds plus 32 thirds plus 6 thirds. So then we get negative 10 thirds plus 32 thirds, so we get 22 thirds. Y'all agree?
Hold on, mathing it. Wait, no.
I see. You need to find a color.
And I turn the calculator on and put
Yeah.
Yeah.
I get the same thing, do it at 2 different ways, so it's probably good.
It probably is.
Okay.
I calculated it and also multiplied it.
What's the domain of this function?
All real numbers.
All real numbers. What's the range of this function?
Great. Less than 22 thirds. Or
Yeah, how do I write that in interval notation?
try that in the
Brackets.
You do little square brackets and then you put 22 thirds.
No.
Oh, you have to do that
Hold
on.
on,
Oh,
how
yes,
do
the
you
other one's
know?
negative.
Oh, because it's big.
Because it goes from down to there.
Yeah.
Yeah? So negative infinity to the thing.
Understood.
I think that negative or 22 thirds is less than negative infinity.
It's definitely not, though. Because you're confused. Or just being obnoxious. Probably the latter. You do get confused, but I don't think this was one of those times. What questions other do we have?
That's
What
the
math
first time
questions
I've
do
ever
we
seen
have?
That is a math question.
No, it's not. All right, say quiz.
Okay, but like I forgot how to do stuff. Spin too long.
Quiz 4-1. Page 224. Numbers 7 and 9.